just to brief you that what we are going to study today and in the upcoming lecture is first we will be studying some introduction as our first topic of conversation is an introduction of big data. So in the first session, we will be studying some introduction of big data tools, machine learning, how machine learning is applied to big data. And then in the upcoming session, that is in the evening, we will be studying some open research areas on big data analytics and how the real-time big data can be used to publish some good quality research and research articles. So we will be studying all that content. Let me just share my screen with you and start with the introduction of our PPT. Is my PPT visible to you, ma'am?
Yes, sir. Yes, sir.
Okay, fine. Thank you. Okay, so we are just starting with this concept of big data, that what actually big data is and what are the introductory concepts of big data. So I will be going through the PPTs one by one. And after that, I will be, as I told you, that I will be going to some hand-on practices on big data, uh, some tools, and some coding as well, using Python as well as MATLAB. And at the end, I will be, introducing some open research areas in big data analytics and this research area. So let's first start with the introduction of our big data tools. Okay, first, what is a big data? Big data is also data, but with huge size. As we know this, it's a kind of a collection of data quantities, characters, or symbols. Classification of big data. See, these are the various parts that we can divide our big data into. It's structured data, unstructured data, geographical data, real-time data, natural language data, time series data, event data, network data, and linked data. So these are the various types of big data that we can be using. Now, let me just introduce you one by one that what these types means. First, let's go to the structured data. Data stored in rows and columns, that is mostly numerical. Unstructured data is the data of different forms, for example, text, image, video, document, etc. Means, see, big data involves various kinds of data, and if I want my data to be properly stored in my rows and columns, then that particular data can be classified as a structured data. And if my data is unstructured or unspecified, it contains several text, images, videos, or documents, then that particular type of data can be termed as unstructured data. Then we have geographic data related to roads, buildings, lakes, addresses, people, workplaces, and transportation routes is termed as my geographic data. Real-time data, real-time streaming of live or stored media data. For example, now we are using real-time data in this particular interaction, in this meeting. This is a part of our real-time data. Natural language data, human generated data, particularly in the verbal form, is my natural language data. Time series data, a sequence of data points or observations, typically consisting of successive measurements made over a time interval. Now, this is important here, point number 6, time series data. What a time series data means, I just want to emphasize on this particular point. Time series is basically uh, recording a time event from a specific date to a specific date. For example, you may have seen few papers on COVID-19. Those research papers, what they have done, they have, you know, sampled the COVID-19 incidence from, say, February of 2020 to December 2020. It covers approximately 10 to 11 months. And in this 10 to 11 months, they considered this period as a time series. Okay, this period of 10 to 11 months, they considered this period as a time series. And based on this time series, they used deep learning algorithm to predict the flow of COVID-19 or any pandemic for that matter. For example, you can predict the future impact of HIV/AIDS or future impact of any other pandemic or future impact of anything. So what I want to emphasize here that my time series data is basically based on some specific dates. Okay, and that is a starting date and an end date, and between those two dates I will collect the data, and I can use that data using machine learning tools, data analytics, to predict future pattern of any particular incidents. Okay, and this can be done by using deep learning algorithms. That is that is also a part of machine learning and AI. So this is our time series data. In the afternoon session, I will just show you that how we can predict, actually predict an incident or a pandemic or anything by using past time series data. Next, we have event data generated from the machine, from matching between external events with time series. Network data concerns very large networks such as social networks. And the final one is our linked data that is built upon standard web technologies such as HTTF, HTTP, RDF, SPA, RQL, and URL. So these are our various types of data that we can, consider in our big data. Now, on a major scale, our big data or our data could be classified into two categories. First is our structured data stored in rows and columns, mostly numerical. For example, database management system. Why our DBMS is a structured data? Because DBMS usually or basically deals with rows and columns only. So DBMS can be termed as our structured data. Sensor data, sensor data. Now this is also a very important term here. I just want to lay emphasis on this particular term, sensor data. We will be studying big data analytics in this tutorial, and dear faculties, we will be studying some real-time implementation of big data analytics, and I will be telling you some open research areas as well in this area. Now, all three these concepts involves big data. And since we are dealing with big data, it is very much important that from where that data is coming. And as far as I have studied big data, I have worked on sensors, I have worked on machine learning and big data. For me, a large chunk of big data or data comes from the sensors or Internet of Things or IoT. Let me just divert a bit from this topic and just open another area of exploration for you. IoT, Internet of Things. Internet of Things mostly consist of sensors that are wireless in nature. Okay, now what a sensor will do, a sensor will basically sense the information, and after sensing the information, it will send the sensed data to a base station. A sensor could be planted anywhere. It could be planted in your college building, in a cinema hall. Sensors are actually everywhere in this present age. On a traffic light to check the speeds, or in a hostile area like forest where humans cannot go. So these sensors are everywhere. Now these sensors sense the information, and after sensing it, they aggregate the entire data, and then they transmit the data to the base station. Now this data that the sensors are transmitting forms a major chunk of big data that we are talking about today. So, sensors and IoT, some researchers may say that no, this is a different research area, but no, dear faculties, this is not a different research area. Sensors, IoT, and big data, they are completely interconnected. Uh, Two of my papers are published on this particular area only, in which I have merged these two topics, that is IoT and wireless sensors, and the big data generated from the sensors. So, going forward, possibly in the afternoon session, we will study that how can I combine these two diverse fields, that is IoT and big data. So this is a brief about the sensor data. Coming back exactly to the topic, sensors generates a lot of data, and for that we will need big data. Now, part number two is your unstructured data. Data of different forms, for example, text, image, video, document, etc. This basically forms our unstructured data. Customer complaints, contracts, or internal emails, since these cannot be, comprised into a tuple or a DBMS system, so this can be termed as our unstructured data. Unstructured data cannot be stored using traditional relational database. Exactly the same thing that I just told you. Uh, then we have your classification digital data. That is geographical data, related to roads, buildings, lakes, addresses, people, workplace, and transportation routes. Geographic information system, place, time, and attributes, urban planning, and for monitoring environmental effects. This forms our geographical data. Then we move forward to our next part, that is real time media, real time streaming of live or stored media data. One of the main sources of media data is services, for example, YouTube and Flickr. Then we have our next type of data, that is natural language data. It is human generated data, particularly in verbal form. Level of abstraction and level of editorial quality. Natural language data includes speech capture devices, land phones, and mobile phones. Internet of Things that generate large sizes of text like communication between devices. Then we move to our next type of data, that is our time series data, a sequence of data points or observations, typically consisting of successive measurements made over a time interval. There are two kinds of time series data: continuous, where we have an observation at every instant of time, and type number two is where we have an observation at usually regularly speed intervals. Okay, so these are two types of time series data. One is where we can make an observation at every instant of time, that is at time t1, t2, t3 up to tn. And type number two is that where we can have an observation at spaced intervals, means we can specify the time instance manually as per our own wish. For example, we want to make an observation at time t4, not at t1. So at t4, t8, t18, manual time intervals. So uh, this is our type number two of time series data. Then we have our event data, that is data generated from matching between external events and time series. Event data consists of three main pieces of information: action, which is event itself; timestamp, the time when this event happened; and the state, which describes all other information, which describes all other information relevant to this event. Event data is usually described as rich, demonetized, denormalized, and nested and schemeless. So this is a bit about our event data. Then we have our second last type of data, that is network data. Data concerns very large networks such as social networks, information networks, for example, the World Wide Web, biological networks, for example, biochemical, ecological, and natural networks, technological networks, for example, internet, telephone, and transportation networks. Network data, sorry, network data is represented as nodes connected via one or more types of relationship. In social networks, nodes typically represent people. In information networks, nodes represent data items. That is web pages. Okay, this is the difference actually. We have to notice here that in social networks, nodes typically represent people, and in information networks, nodes represent data items, for example, web pages. In technological networks, nodes may represent internet devices, for example, router and hubs, or telephone switches. And in biological networks, nodes may represent neural cells. So this is our network data that consists of various kinds of nodes, and nodes represents different entities and different features according to the types of networks they are in. Then we have our final type of data, that is linked data. Data that is built upon standard web technologies such as HTTP, RDF, SparkQL, and URI to share information. Examples of repositories for linked data include DBpedia, a dataset containing extracted data from Wikipedia. Okay, geonames, RDF descriptions of more than 7 lakh, 7 crore 50 lakh geographical features worldwide. UMBEL, a lightweight reference structure of 20,000 subject concept classes and their relationships derived from OpenCYC. FOAF, friend of a circle, a data set describing persons, their properties, and their relationships. Linked open data is another project that targets linked data with open content. So this is our PPT number one, and that studied about various kinds of data. Uh, just a second. Yeah, dear faculties, was it clear to all of you? I tried my best explaining various kinds of data. It would be good if you can please respond a bit.
Sir, we will continue, sir.
Yes, ma'am. I was clearly audible?
Yes, sir.
Okay, fine. So now we'll continue with our next PPT. Our next PPT is just a second. Okay, now we'll study a bit about big data and its importance. The big data concept and technologies basically include collecting, storing, and processing. This type of data opened up new opportunities for business world. Big data and its importance includes analysis, for example, comments on social media, history of surfing around an online store for 47 plus million unique monthly visitors, new business tasks such as sentiment analysis, recommendation engines, 360-degree customer view. In a world with big data, companies are able to gain a more complete understanding of their business, customers, products, and competitors, etc. The importance of big data does
Sir,
not.
excuse me, sir. Screen
Yes,
is not visible, sir.
screen is not visible to you.
Yes, sir.
Just a second, just a second. Thank you for informing me. Just a second. Is it visible now, ma'am?
No, sir. Now it is okay, sir. Now it is visible.
Okay, thank you, thank you. Please inform me if my screen is not shown at any point of time. Okay, please let me know. Okay, so let's continue with our PPT. Big data and its importance. The importance of big data does not revolve around how much data a company has, but how much a company utilizes the collected data. Every company uses data in its own way, and the more efficiently a company uses its data, the more potential it has to grow. The company can take data from any source and analyze it to find answers which will enable cost savings, time reductions. These are basically why our big data is important. Okay, this PPT will be explaining why big data is important. Cost savings, time reductions, understand the market conditions, control online reputation, using big data analytics to boost customer acquisition and retention, using big data analytics to solve advertisers' problem and offer marketing insights, big data analytics as a driver of innovations and product development. Cost saving, some tools of big data like Hadoop and cloud-based analytics can bring cost uh, advantages to business. Time reduction, the high speed of tools such as Hadoop in memory analytics can easily identify new sources of data. Third point is understanding the market conditions. By analyzing big data, you can get a better understanding of current market conditions. Point number four is control online reputation. Big data tools can do sentiment analysis. Now, sentiment analysis is a big thing here, uh, and it's a kind of part of big data analytics as well. I'm very much sure that all of you must have heard about sentiment analysis, and a large amount of research has been going on this particular area. So later in the session, when I will be discussing on open research areas, I will be discussing sentiment analysis as well in the afternoon session. Point number five is using big data analytics to boost customer acquisition and retention. The use of big data allows businesses to observe various customer related patterns and trends, using big data analytics to solve advertisers' problem and offer marketing insights. Big data analytics can help change all the business operations. And finally, big data analytics as a driver of innovations and product development. Another huge advantage of big data is the ability to help companies innovate and redevelop their products. So, best examples of big data are big data in education industry, such as customized and dynamic learning programs, reframing course material, grading systems, uh, career prediction, and point number two is big data in insurance industry for to be used in collecting information, gaining customer insight, fraud detection, and threat mapping. Then we have four V's of our big data, that is volume, variety, velocity, and veracity. volume, the parameter has moved from gigabyte to terabytes and beyond. In fact, I would say it's now moving from terabytes to exabytes. Okay, because the amount of data since 5G has been introduced, and 5G basically contains IoT. It is its backbone is IoT, and the backbone of IoT is sensors. And what sensors do? Sensors generate a huge amount of data. So since the introduction of 5G, the volume has moved from terabytes to exabytes. In fact, then we have variety. This defines the type of data source and whether it is generated by a machine or a people. Then we have velocity. This parameter defines the generation speed of data. This grows by the moment and entails huge volumes. And the fourth point is veracity. This parameter defines the data quality and at times is out of the analyst's control. So this was about importance, that why our big data is important. Then we move on to our next PPT. Top challenges facing big data. Data is very valuable asset in the world today. The economics of data is based on the idea that data value can be extracted through the use of analytics. The importance of big data analytics will continue to grow in everyday lives, both personal and business. The key to data value creation is big data analytics, and that is why it is important to focus on that aspect of analytics. Many companies use different methods to employ big data analytics, and there is no magic solution to successfully implementing this. Top challenges facing big data and big data analytics as well. Dealing with data growth. See, dear faculties, we are presently studying Introduction to Big Data. I have divided this entire session of today and the upcoming session into four parts or four units. This is, you can say, our unit number one, that is Introduction to Big Data. Then we will move to our next unit, that is getting to know some big data tools. Then we'll move to our unit number three. In that, we will study some open research areas. And in last, that is unit number four that I have designed. In that, we will have some hand-on practices on some latest big data tools. So presently, we are just going through unit number one to have an introduction to recent trends in big data. And let's continue with that. These are the top challenges facing big data: dealing with data growth, generating insights in a timely manner, recruiting and retaining big data talent, integrating disparate data sources, validating data, securing big data is a problem because there are many intruding and hacking attacks nowadays on a company's database. And finally, organizational resistance is another challenge to big data and its and big data tools. Now we'll study them one by one, the challenges that are faced by big data. First one is dealing with data growth. Obviously, this is the biggest issue that big data is facing presently. The most obvious challenge associated with big data is simply storing and analyzing all the information, because there is a huge amount of information, and storing and assessing and analyzing all that information is not easy. So the first and a very obvious problem with big data is to just store and use all the huge amount of data or information that is associated with big data. The amount of information stored in the world's IT system is doubling about every 2 years. It means, as it self-explains, self-explanatory, this particular sentence, that the amount of information that is stored in world's IT systems is actually getting twice about every 2 years. This is a problem. because obviously the size of the data is increasing, and we have to manage all that, increased amount of data. Then we have much of the data is unstructured. Unstructured means that it don't reside in the database. Now, structured data is okay because it can go straight into our DBMS structure, that is rows and tuples, rows and columns. But if the data is unstructured, that is, there is no particular structure of a big data, then there is a problem. And this is one of the issues in dealing with big data analytics. Documents, photos, audios, videos, and other unstructured data can be difficult to search and analyze, quite rightly said. Organizations are turning to a number of different technologies when it comes to storage, converged and hyper-converged infrastructure, and software-defined storage can make it easier for companies to scale their hardware. And technologies like compression, deduplication, and tiering can reduce. Uh, Compression is compressing the data. Deduplication is to remove redundancy of the data. That is, I don't want duplicate entries in my big data. And tiering is classifying the data into various tiers. Can reduce the amount of space and the costs associated with big data storage. Tiering is the assignment of performance-based and cost-based storage tiers of different types of two different types or tiers of data storage, processing, and retention. There are two types of data tiering: hardware level tiering and software level tiering. On the management and analysis side, companies are using tools like NoSQL database. We'll study it now in the upcoming PPTs. What is NoSQL? Hadoop, Spark, big data analytics software, business intelligence applications, artificial intelligence and machine learning to help them comb through their big data stores and find the insights their companies need. Then we have generating. These are the challenges that our big data analytics is facing. We are studying the challenges that our big data analytics are facing. Point number two is generating insights in a timely manner. Organizations don't just want to store their big data, they want to use that big data to achieve business goals. According to the New Vintage Partners survey, the most common goals associated with big data projects included the following: decreasing expenses through operational cost efficiencies, establishing a data driven culture, creating new avenues for innovation and disruption, accelerating the speed with which new capabilities and services are deployed, launching new product and service offerings. So these are the various goals associated with big data projects nowadays. Uh, all of those goals can help organizations become more competitive, but only if they can extract insights from their big data and then act on their insights quickly. PC's Global Data Analytics Survey found everyone wants decision making to be faster, especially in banking, insurance, and healthcare. Quite rightly said. To achieve that speed, some organizations are looking to a new generation of ETL, that is, extract, transform, and load, and analytics tools that dramatically reduce the time it takes to generate reports. They are inventing, they are investing in the softwares with real-time analytics capabilities that allows them to respond to developments in the marketplace immediately. Then ETL, that is extract, transform, and load, is a general process for replicating data from systems to target systems. It encompasses aspects of obtaining, processing, and transporting information so an enterprise can use it in applications, reporting, or analytics. As you can see in the figure here, this is the process of our ETL. It is extract, transform, and load, and then analyze using big data analytics. Extract is basically event data or transactional data. Transform is transforming that data. Then we load that data, and finally we analyze that data using big data analytics tools. And then we have your extract. Extraction involves assessing source systems and reading and copying the data they contain. The data engineer may extract source data to a temporary location, such as a data lake or a staging table in a database, in anticipation of steps that follow. Now, what is a data lake here? Data lake is a centralized repository for hosting raw, unprocessed enterprise data. Data lakes can encompass hundreds of terabytes or even petabytes, storing replicated data from operational sources, including databases and SaaS platforms. Then we move to step number two, that is transformations. Transformations fall in three general categories: validating, cleaning, and preparing data for analysis. See, if I want to use data analytic tool and wants to do data analysis, these are the steps that I need to follow. I cannot just straight away. We cannot just straight away go to data analytics. We have to follow these steps, that is extract, transform, and load, and then we can move to our analysis part. So some of the most important transformations are mapping data types from source target systems, flattening semi-structured data intended for relational database and data validation. And the final one is our load. The loading stage involves writing data into a target, which may be a data warehouse, data lake, or analytics application, or platform that accepts direct data feeds. Data can exist in multiple final stages and locations within a destination. For example, in a data warehouse, the same records might exist as part of a snapshot table, including a week of data, and in a larger archival archival table consisting all loaded historical records. Recruiting and retaining big data talent. In order to develop, manage, and run those applications that generate insights, organizations need professionals with big data skills. That has driven up the demand for big data experts, and big data salaries have increased dramatically as a result. So this they are just giving an example that how a data scientist is paid, why a data scientist is presently in so much demand, and what are the expected salaries that a big data analytics or a data scientist gets in this present age. This is why this is a very hot area of research in the present age. It's explaining the same thing here. Yeah, this is another big issue: securing big data. Security is also a big concern for organizations with big data stores. After all, some big data stores can be attractive aims or targets for hackers or advanced persistent threats. However, most organizations seems to believe that their existing data security methods are sufficient for their big data needs as well. Encryption Your encryption tools need to secure data in transit and at rest, and they need to do it across massive data volumes. Centralized key management best practices include policy driven automation, logging, on demand key delivery, and abstracting key management from key usage. User access control. User access control may be the most basic network security tool, but many companies practice minimal control because the management overhead can be so high. Policy driven automation manages complex user control levels like multiple administrator settings that protect the big data platform against inside attack. Intrusion detection and prevention systems are security workhorses. Um, and then we have physical security. Don't ignore the physical security, but uh, build it in when you deploy your big data platform in your own data center. Physical security systems can deny data centers access to strangers or to staff members who have no business being in sensitive areas. Video surveillance and security logs will do the same. So, this is a bit about securing big data and big data analytics. And then we have organizational resistance based on survey report response. Respondents pointed on three big obstacles within their organizations: insufficient organization alignment, a lack of middle management adoption and understanding, and business resistance or lack of understanding. It means the when the issue comes from within an organization in implementing big data analytics. So this is about our PPT regarding challenges and various aspects of our big data. That what are the challenges that a big data or big data analytics is facing in this present era. Now we move on to our next PPT here. Now, big data analytics. Big data analytics is often complex process of examining large and varied data sets or big data to uncover information including hidden patterns, unknown correlations, market trends, and customer preferences that can help organizations make informed business decisions. Data analytics technologies and techniques provide a means to analyze data sets and draw conclusions about them to help organizations to make informed business decisions. Then we move on. Big data analytics is a form of advanced analytics which involves complex applications with elements like predictive models, statistical algorithms, and what if analysis powered by high performance analytics systems. The importance of big data analytics, the performance of the importance of big data analytics driven by specialized analytics system and software as well as high powered computing systems. Big data analytics offers various business benefits including new revenue opportunities, more effective marketing, better customer service, improved operational efficiency, and competitive advantages over rivals. Here we can see that it is shown as four types of analytics here. Descriptive, excuse me, yeah, descriptive, diagnostic, predictive, and prescriptive. So these are the four types of data analytics that we'll be studying. What the data, what is data explaining to you. First one is descriptive. What's happening in my business? Okay, means a kind of a description about big data and big data tools. Comprehensive, accurate, and live data. Effective visualization. Then we have diagnostic. Why is it happening? Okay, these are the part of my big data analytics. As you can see in this image, where we are studying them one by one. Descriptive, that is what is happening in my business. Comprehensive and accurate and live data. Effective visualization. Then we have diagnostics. What is happening in my data, that is ability to drill down to the root cause, ability to isolate all confounding information. Then we have predictive, that is what's likely to happen. Business strategies have remained fairly consistent over time. Historical patterns being used to predict specific outcomes using algorithms. Decisions are automated using algorithms and technology. Then we have prescriptive. What do I need to do? That is a sort of prescription. It states the recommended actions and strategies based on champion slash challenger testing strategy outcomes, applying advanced analytical technologies to make specific recommendations. Uh, then we have our point number one, that is what is happening. As you can see, we have represented it with an image. This is the most common of all forms in business. It provides you the analyst a, a key a view of key matrices and measures within the business. An example of this could be a monthly profit and a loss statement. Similarly, an analyst could have data on a large population of customers. Understanding demographic information on their customers, for example, 30% of our customers are self employed, would be categorized as descriptive analytics. Utilizing effective visualization tools enhances the message of descriptive analytics. Then we have diagnostics, that is what is happening. These are the part of your big data analytics. Okay, and as I showed you in the image earlier, these are the parts of your big data analytics that we are presently studying. Yeah, then we have diagnostics. Why is it happening? Okay, this is the next step of complexity in data analytics, that is descriptive analytics. On assessment of descriptive data, diagnostic analytical tools will empower an analyst to drill down and, in so doing, isolate the root cause of a problem. Well designed business information dashboard incorporating reading of time series, that is data over multiple successive points in time. As I told you earlier, what is a time series? It's also saying that it is the data over multiple successive points in time, and featuring filters and drill down capacity allow for such analysis. Then we have predictive, that is what is likely to happen. Okay. Predictive analytics is all about forecasting. As I told you, these all are the part of your big data analytics. Part number three is predictive analytics. It is all about forecasting, whether it's the likelihood of an event happening in future, forecasting a quantifiable amount of estimating a point in time at which something might happen. These are all done through predictive models. Predictive models typically utilize a variety of variable data to make the prediction. The variability of the component data will have a relationship with what is likely to predict. For example, the older a person, the more susceptible they are to a heart attack. we would say the age has a linear correlation with heart attack risk. These data are then compiled together into a score or prediction. In a world of great uncertainty, being able to predict allows one to make better decisions. Predictive models are some of the most important utilized across a number of fields. I told you, dear faculties, in the beginning of the session that a part of big data and big data analytics is prediction models. Prediction models based on past time series or based on deep learning techniques. And you will see that there are, for instance, presently we are facing COVID-19 pandemic, and we can try to build a prediction model for COVID-19 based on our past analytics data. So this is one of the real time or very important advantage or use of our predictive data analysis. Then we have prescriptive, that is what do I need to do. Then the step in terms of value and complexity is the prescriptive model. The prescriptive model utilizes an understanding of what has happened, why it has happened, and a variety of what might happen analysis to help the user determine the best course of action to take. Prescriptive analysis is specifically not just with one individual action, but is an fact to host of other actions. A good example of this is a traffic application helping you choose the best route home and taking into account the distance of each route, the speed at which you can travel on each road, and crucially, the current traffic constraints. So this basically specifies that what you need to do regarding your big data analytics. So this was about your big data analytics and its various kinds of parts. It contains, as I told you, it contains four parts, that is descriptive, diagnostics, predictive, and prescriptive. So I have just explained all the four parts here in this PPT. Next, we'll move forward. Now let's study a bit more about big data in brief. I think I have explained these concepts to you. I think this PPT, I have explained this to you already. Yeah, I have explained this. However, I will share all these PPTs with ma'am so that you can also have a look at these PPTs and you can also use these PPTs. I will share all this content. So let's move to the next one. Yeah, this is important. This I should be explaining. This basically explains your big data architecture and patterns. Big data solutions typically involve one or more of the following types of workload: batch processing of big data sources at rest, real-time processing of big data in motion, since we will be studying real-time processing as well in the upcoming sessions, interactive exploration of big data, predictive analytics of machine learning. Most big data architectures include some or all of the following components: data source, data storage, batch processing, real-time message ingestion, stream processing, analytical data store, analysis, and reporting and orchestration. So these are the major components of your big data batch processing. This is the architecture that I wanted to show you. You can see here. Data source, initially then we have data storage, real-time message ingestion, batch processing, stream processing. Real-time always includes stream processing. because if I use batch processing for real-time message ingestion, it will not work. Since we need real-time processing, uh, and if I use batch processing in conjunction with real-time message ingestion, then batch processing operates in specific batches. Once a particular batch will travel, then another batch will travel. There is no continuity in the batch processing. So for real-time message ingestion that we will be studying in the upcoming sessions, I need stream processing. This is my only solution. Then we'll calculate analytical data store, and then analytics and reporting. So this is a basic architecture of your big data analytics. Let me move on to our next PPT. Again, let's study a bit more about big data and analytics. Big data is a field that treats ways to analyze, systematically extract information from huge data, otherwise deal with data sets that are too large or too complex to be dealt with by traditional data processing application software. So this is basically shows the storage upgradation, or how we have upgraded or moved from traditional data storage mechanisms to our big data mechanisms. As we can see that earlier we used to use floppy disks for storage of data, and from 1986 when we used analog medium to store data, we have moved towards floppy disk in 1993. In 2000, we had another, upgradation. In 2002, there was a beginning of digital age. And see, this dotted line is basically 2002, okay? Up to this, the growth was very slow, very slow. And after the beginning of digital age, it exploded, isn't it? It exploded because digital storage came into picture after year 2002. And after the beginning of the digital age, you can see CD-ROM being introduced, DVDs are being introduced, and various, high speed and highly efficient storage devices are being introduced after beginning of the digital age. Now, this is important here. This is very important here. Uh, this basically shows a screenshot of Flipkart if I want to buy a Lenovo laptop. Okay. Now, what I want to show you here, why I have added this image here, is basically there are reviews on a particular product. Okay, there are reviews. How these reviews are obtained? How these you can see it's given as 4-star rating. Okay, so how these reviews are obtained? This all is governed by a concept called sentiment analysis. Sentiment analysis. So what basically a sentiment analysis is, you open your YouTube. I'm just going forward into this session, and I just want to explain you something important. You open your Facebook or your YouTube, okay, and you see a particular video on a YouTube of a specific movie. Now, when you open your YouTube next time, the YouTube search engine will automatically recommend you the video of your choice. How does it do that? How does it do that? It do that by using sentiment analysis, because it analyzes the sentiment of a user and how to perform a sentiment analysis. That I will show you. That I will show you. I have the code with me. I have the Python code with me. I have the data that I collected from a website. For example, you open your Flipkart, and after opening your Flipkart, you can just get the data from there as well. So how to do a sentiment analysis, that I will show you in the afternoon session, but just wanted to introduce this concept to you. That sentiment analysis is also a part of big data and big data analytics, and we will be studying it. All these comments, they form a part of sentiment analysis. Okay. Then we have IBM. Big data analytics is the use of advanced analytic techniques against very large, diverse data sets that include structured, semi-structured, and unstructured data from different sources and in different sizes, from terabytes to zettabytes. Big data is a term applied to data sets whose size or type is beyond the ability of traditional relational databases to capture, manage, and process the data with low latency. Characteristics. Big data has one or more of the following characteristics. I have already explained this to you: high volume, velocity, and high veracity. We have shown this by an image. Uncertainty, robustness, these are all characteristics of big data actually. Uncertainty, robustness, trustworthiness, accountability, statistical correlations, prediction, hypothetical, high dimensional, terabytes, transactions, tables, files, real time, online acquisition, sustainability, processes, structured, semi-structured, unstructured, and multi-factor. These are all characteristics of my big data analytics. Now, reason for big data analytics. Why do I need big data analytics? That is also important. Uh, Let me just explain you a bit here. Yeah, analysis of big data allows analytics researchers and business users to make better and faster decisions using data that was previously inaccessible or unusable. Businesses can use advanced analytics techniques like text analytics, machine learning, predictive analytics, data mining, statistics, and natural language processing to gain new insights from previously untapped data sources independently or together with existing enterprise data. So these are basically the reasons why I will need my big data analytics. Now we move further in the ladder uh, to the next topic. We move to Hadoop now. Hadoop is also an important part of big data and its analytics. Hadoop architecture. What is Hadoop? Hadoop is an open source software programming framework for storing a large amount of data and performing the computation. Its framework is based on Java programming with some nav code in C and shell scripts. As I told you that this is a part of your, unit number 2. I have divided this entire session into 4 units. Unit number 1 and 2 are basically introduction or getting to know big data and big data analytics. Your unit number 3 will be some open research areas of your big data analytics. And the final and unit number 4 will be some hand-on practices on some big data analytics tools. So we are into unit number 2 here. Hadoop ecosystem. Hadoop ecosystem is a platform or a suite which provides various services to solve the big data problems. It includes Apache products and various commercial tools and solutions. There are 4 major elements of Hadoop, that is HDFS, MapReduce, Yarn, and Hadoop Common. We will be studying all of them in this session. These are important. Uh, Most of the tools or solutions are used to supplement or support these major elements. All these tools work collectively to provide services such as absorption, analysis, storage, and maintenance of data, etc. Hadoop ecosystem. Now, this is a Hadoop ecosystem architecture. Um, your row number one is your data management, and what are the tools that I use for data management are Uzi, Chokwa, Flume, and Zookeeper. These are our data management tools. Then after managing the data, I need to assess the data. And for data access tools, I have Hive that uses SQL. I have Pig, I have Mahout, I have Avro, I have Scoop, that is RDBMS connector. And then I need data processing. And for data processing, I have two of them. That is MapReduce, cluster management, and Yarn, that is cluster and resource management. We will be studying all of them. And the last but not the least is our data storage. It includes our HDFS, that is the file system, and HBase, that is column database storage. So this is a Hadoop ecosystem. All this comes under the umbrella of Hadoop. Hadoop is important. It's very important, and we need to understand it properly to go ahead with our real-time data analytics and to work with our real-time tools. So I'll just brush upon some important topics of Hadoop and these parts of Hadoop. And after that, we will be moving on further to some open research areas of big data analytics. So following are the components that collectively form a Hadoop ecosystem: HDFS, Hadoop Distributed File System. Yarn stands for yet another resource negotiator. MapReduce is basically programming-based data processing. Spark is in-memory data processing. Pig or Hive is query-based processing for data services. HBase is basically no SQL database. This is important. We'll study it, dear faculties. Then we have Mahout, Spark, ML, Lib. These are machine learning algorithm libraries. Then we have Solar and Lucene, that is searching and indexing. Then we have Zookeeper, that is managing cluster. And then we have Uzi, that is job scheduling. This is the architecture in the image form. As you can see here, there is a MapReduce layer, and there is a HDFS layer, and there's a master node here, and then we have two slave nodes, and the master node is operating these two slave nodes using MapReduce and HDFS. Going further into our Hadoop architecture, Hadoop has a master slave architecture for data storage, as I just explained you, and distributed data processing using MapReduce and HDFS methods. Name node represented every files and directory which is used in the namespace. Data node helps you to manage the state of an HDFS node and allows you to interact with the blocks. The master node allows you to conduct parallel processing of data using Hadoop MapReduce. The slave node are the additional machines in the Hadoop cluster, which allows you to store data to conduct complex calculations. Moreover, all the slave node comes with the task tracker and a data node. This allows to synchronize the processes with the name node and job tracker separately. This is a Hadoop architecture, as I just explained to you. Name node is a master, and data nodes, that is commonly the hardware, are being processed by the name node. Hadoop distributed file system, that is HDFS. Now, HDFS is a block structured file system where each file is divided into blocks or a predetermined size. These blocks are stored across a cluster of one or several machines. Apache Hadoop HDFS architecture follows a master-slave architecture where a cluster comprises of a single name node, that is the master node, and all the other nodes are data nodes, that is the slave nodes. HDFS can be deployed on a broad spectrum of machines that support Java, though one can run several data nodes on a single machine, but in the practical world, these data nodes are spread across various machines. This is again an HDFS architecture. You have client and you have your data nodes in your rack 1 and data nodes in your rack 2. Name nodes is basically operating them, and as you can see that the block operations are being performed by the name nodes in the respective data nodes in rack 1 and rack 2. Then we have your distribute blocks of data sets across multiple nodes. Each node has its own computing power. Replication distributed file system will also replicate data blocks on different clusters by copying the same pieces of information into multiple clusters on different racks. This will help to achieve the following. First one is the fault tolerance, recover data block in case of cluster failure or rack failure, and high concurrency, that is avail some piece of data to be processed by multiple clients at the same time. It is done using the computation power of each node to parallel process data blocks. Then we have some features of HDFS. It is suitable for the distributed storage and processing. Hadoop provides a command interface to interact with HDFS. The built-in servers of name node and data node help users to easily check the status of the cluster. Streaming accesses to file system data. HDFS provides file permissions and authentication. Then we have the name node. The name node is the commodity hardware that contains the GNU Linux operating system and the name node software. It is a software that can be run on a commodity hardware. The system having the name node acts as a master server, and it does the following tasks: manages the file system namespace, regulates clients' access to files. It also executes file system operations such as renaming, closing, and opening of files and directories. This is the work of our name node. Then we study about data node. The data node is a commodity hardware having GNU Linux operating system and a data node software. For every node commodity hardware system in a cluster, there will be a data node. These data nodes manage the data storage of their system. Data nodes perform read-write operations on the file systems as per client request. They also perform operations such as block creation, deletion, and replication according to the instruction of the name node. Then we have a block. Generally, the user data is stored in the files of HDFS. The file in a file system will be divided into one or more segments and stored in individual data nodes. These file segments are called as blocks. The Just a second. Hello. Okay, just wait. Okay, so we were just studying about Hadoop, dear faculty members, and while studying about Hadoop, before going forward, because now we will be studying about various parts of Hadoop architecture. But before going forward, I would just like to introduce or explain to you some open research areas that we can use
Sir,
in
please.
our.
Sir, sir, one second. Your screen is not visible now, sir.
Okay, ma'am, I'm just opening it, no problems.
Okay. Ah.
Just a second. Is it shown now, ma'am? Is it visible now?
Now it is visible, sir.
Okay, okay, fine, fine. So,
Oh,
so what I was explaining you, dear faculty members. So we're just studying about Hadoop, and now we'll study about some open research areas of our big data analytics and Hadoop. And after going through these open research areas, we will be uh, studying about parts of Hadoop. But before going forward and before continuing towards a part of Hadoop, I think this is the best time to introduce some open research areas using big data analytics and Hadoop. And if you pay, I wish, I hope, and I want that all of you pay good attention to this particular session, because in this session I will be explaining you some very good research topics, and by using them and by working on them you can publish some good quality SCI research papers. Believe me, using these topics that I will be just explaining you in this upcoming PPT, I myself has published two SCI indexed research papers in Elsevier. So this PPT is going to be very important, and this is directly connected to your big data and big data analytics. And in this PPT, or throughout the course of this PPT, I will be explaining you some quality open area of research. Okay, so let's start it. Nature inspired algorithms in big data. See, nature inspired algorithms is a part of artificial intelligence. Artificial intelligence is a big cloud, it's a huge cloud, and artificial intelligence contains various parts, for example, machine learning, deep learning techniques like LSTM, GRU, RNN. These are all my deep uh, ANN, that is artificial neural networks. These are all my deep learning machine models. And a third aspect contains nature inspired algorithms. It is also connected to your real time analytics. So let's just start it first. What is big data? I have already introduced to you. Let me just explain it once more. Big data is a novel field and an open area for research. We are now in digital world. Amount of data being processed every day is increasing rapidly. The data being stored, the data being generated or produced from different fields like retail, healthcare, social media data, and public domain data, etc. If we wish to store this amount of data onto DVDs, there will be a stack of DVDs from Earth all the way to Mars. And according to an approximation, 30 million content is shared on Facebook every month. To handle such huge flow of data, big data was introduced, and big data handles large amounts of data in an efficient manner. So, I already explained these points to you, that it contains of velocity, volume, and variety. Now, this is the business area. This is the main area, IoT. Now, although it does not directly connect with your big data, but your data comes from somewhere. Okay, from where that data is coming? The data is coming from sensors. And where are your sensors located? Those sensors are located in your IoT. So let me just brush upon this concept, and then we will come back to the big data. IoT consists of a group of sensor nodes that interact with each other to extract useful information from real time data. IoT consists of sensors. Since the sensors in IoT have very limited energy, this kind of scenario is not desirable. The lifetime of an IoT depends upon the cluster head lifetime, which makes optimum use of cluster head battery an important parameter for an energy efficient IoT network. This is a basic architecture of your IoT. Okay, these round shapes are your sensor nodes. This star is your cluster head in the center, and this is your sink or the base station. Now, what they do, every sensor node collects the data, sends the data, they send the data to their cluster head, and the cluster head send the data to the base station. Now, note how many times I have repeated the word data here, okay? Because it's all about data. Sensor nodes deals with a huge amount of data, and we are using big data here. We are studying big data analytics here. So it is very important for us to know that from where that data is coming. So that is why it's always good to connect two interdisciplinary areas, and using that we can form a quality research article. So these are some of the parts or the performance issues in IoT. uh, uh, First is the energy efficiency in IoT, second is balancing the load of IoT, and third one is the mobile sync of IoT. These are the research problems of IoT. uh, this again shows the big data parameters in a IoT or wireless sensor domain. Here, it shows that it contains volume, variety, and velocity, social media data, transaction data, and sensor data. Wireless sensor network and big data. Above, we saw the utility of nature-inspired techniques in wireless sensor networks. BBO stands for biogeography-based optimization. It is a machine learning or a nature-inspired algorithm. EBBO is extended biogeography-based optimization. It is again a machine learning or a nature-inspired algorithm. And PSO stands for particle swarm optimization. It is again a machine learning or a nature-inspired algorithm. So above we saw the utility of nature-inspired techniques in wireless sensor networks. BBO, extended BBO, and particle swarm optimization, that is PSO, are successfully used to achieve an energy efficient wireless sensor network. The amount of data emerging from wireless sensor is huge, which encourage the use of big data tools in wireless sensor network data. A wireless sensors scenario can operate effectively if it is merged with big data techniques. In the next section, we study how nature inspired techniques or how your machine learning or artificial intelligence techniques can play a crucial role in optimizing the performance of big data tools. Let's now just study some of the machine learning and nature inspired algorithms, since it is also a part of our session or this particular webinar. This webinar is based on machine learning and nature inspired or artificial intelligence algorithm using big data analytics. So let's just study some of the artificial intelligence algorithms or machine learning algorithms, you can say. First is BBO and extended BBO. BBO, that is biogeography based optimization. It was introduced by Dan Simon in 2008, and it was an improvement of particle swarm optimization. Initially, genetic algorithms was introduced by Holland in 1974, and after that, dear faculties, particle swarm optimization, that is PSO, was introduced by Schultz in 1997, and particle swarm optimization performed well for 8 to 9 years. And after that, in 2008, BBO, that is biogeography based optimization, was introduced, and it outperforms both its previous algorithms like the genetic algorithm and particle swarm optimizations. Its advantages are that it does not stuck at a local optima. I will just read them out for you. We find that most of the parameters uh, we find that most of the past researches only used elementary swarm-based algorithms like GA and PSO for optimization. Here we will be using biogeography-based optimization BBO and extended BBO, which are successfully used in the past for many applications such as remote sensing, face recognition, and feature extraction. We are mapping and adopting BBO and modified BBO in our work, that is big data analytics. Uh, let's have a brief introduction about BBO. BBO is an evolutionary algorithm or a machine learning or a ML technique which depends upon migration of species. The goodness of a habitat is given by its habitat suitability index, that is HSI, or the fitness value. Immigration and emigration forms the migration step of PBO, that is biogeography-based optimization. This is the flowchart of your biogeography-based optimization, dear faculties. First, we'll start. As I told you, that any machine learning or nature-inspired technique can consist of 3 to 4 basic steps. First is the initialization. After that, it contains the calculation of fitness values, and based on the fitness values, there will be migration operation performed, and after migration, there will be mutation operation performed, and after that, we obtain the optimum solution. So this flowchart explains all those 4 steps of BBO. Then we move on to extended BBO. Extended BBO is a extended version of BBO, and that was an improved version of BBO. It was proposed by myself and my PhD supervisor, Professor Daya Gupta, in year 2015. This extended BBO. What we did, we tweaked or we altered or modified the basic parameters of BBO, and we achieved a better optimization performance of this machine learning algorithm in various areas like uh, feature extraction, image processing, or even big data. We applied it to big data as well, and we obtained better results than BBO. uh, I will just read it out for you. In extended BBO, HSI, or the fitness value of a habitat, does not depend only on immigration and emigration. Instead, it is a function of varying characteristics of a habitat. Above equation shows that HSI of ith habitat is a function of various combinations of its SIV. SIV is suitability index variable, or a particular, you can say a particular candidate solution. SIV is a particular candidate solution. The SIVs which are not applicable for a particular habitat are removed in the HSI or the fitness calculation by making their coefficient 0. And this is the flowchart of your extended BBO. It shows exactly what I have just explained to you. Now, the role of nature inspired techniques or machine learning techniques in extension and the extension required for the present work on big data. Uh, Nature inspired techniques can be usefully applied to data mining and big data. In the past, swarm intelligence techniques are successfully used in big data domain. There are two kinds of approaches in which swarm intelligence can be used in data mining and big data. In the first class, individuals of swarm moves towards a solution space and try to search for a solution for the big data task. This is called the search approach. The swarm intelligence is applied to optimize the data mining or the big data search. Yeah, quite obviously, because big data or data mining, all this process includes searching of a particular data set from a huge volume of data. If I want to go to real-time big data analytics, what does that mean? Real time big data analytics. It means applying big data tools or techniques in real time. Why we need real time? Because there are many time sensitive applications in use presently. For example, in a healthcare system, if there is a patient that is being operated presently and I want the ECG report of that patient in real time. And if that ECG report or that ECG report data comes to me after 2 or 3 minutes, the patient may die by that time, isn't it? So this is a problem. So that is why we need real-time big data analytics, and this is the significance of this particular session, and this is why this topic is being chosen by the organizers quite understandably. That real-time is important in present age in every aspect. We have seen the introduction of 5G. What 5G has done? Okay, there were earlier we had 4G, but now 5G has been introduced as an upgraded version of 4G. What 5G has done, dear faculties, basically it has reduced the latency. This is the major contribution of 5G. Why do I want to reduce the latency? Because I need real-time data processing. This is why I need 5G. So you can see anywhere in any facet of life, in any aspect of life, real-time data or real-time data analysis is the key, is the name of the game. And this is why we need real-time data or real-time data processing here. So coming back to the uh, present area that we were studying, in the first class of individuals of a swarm moves through the solution space and try to search for a solution of the big data task. This is called as the search approach. The swarm intelligence is applied to optimize the data mining, big data search. The second class is called data organizing approach, in which the swarm intelligence is directly applied to the data samples. Since PSO is successfully implemented for data mining big data tools, better techniques like BBO, extended BBO can be tried and implemented for the same purpose. Better nature inspired techniques like BBO and extended BBO have shown very good re- results uh, in the area of wireless as well as in the area of big data as explained above. They are successfully used in wireless sensors to achieve load balance, stable, and energy efficient structure, which encourages the use of such techniques in big data as well as wireless sensors. And as we can see, that wireless sensors and big data are very much similar. So what I wanted to explain you from this PPT is that, you know, If you want to work only on big data alone, that won't do you a huge advantage. If you want to do some very quality research, try to merge two areas into one. Try to combine any two areas. It could be any two areas, but try to combine any two areas and work on that. If you are working by uh, combining two separate areas, then the research that will be coming out of it will be quality, and there will be a high possibility of acceptance of your research article. So here I have just shown you that how you can merge IoT with big data analytics. And if you combine both of them, in fact, here you are combining three areas: IoT, artificial intelligence, and along with that, you are combining big data analytics. So you are combining three areas. If you if you can work on this, if you can find a proper algorithm on this, it can make a very good quality SCI or your IEEE transaction paper. Then we have your research areas, open research areas on big data. Big data techniques involve mining of a huge amount of data at a rapid speed, that is large data sets to be processed within a limited amount of time. This is very similar to what wireless sensor network data needs. In wireless sensor networks, we need to find appropriate set of data at fast speed out of huge data sets. For this requirement, big data tools can be effectively used. This analytic problem can be referred as an optimization problem. The term optimization refers to finding the best possible solution in a limited amount of time out of numerous number of available solutions. The problem can be solved as an optimization problem using nature-inspired and machine learning algorithms like BPO and extended BPO. Since these algorithms have already shown re- uh, very good outputs in wireless sensor networks, although the big data suffers from curse of dimensionality problem, that is performance of mining data degrade as the size of data set increases. Obviously, this is a big problem. This problem can also be solved as an optimization problem using nature-inspired algorithms. The big data coming from sensors deployed in healthcare systems, traffic monitoring, challenge, changes rapidly with time. Swarm intelligence and other nature inspired techniques can be successfully used in handling dynamic changes in big data. In swarm intelligence and other nature inspired algorithms, measures are taken so that they solve dynamic problem satisfactorily. Hence, these nature-inspired techniques can be used to cater for the dynamic requirements of big data. So these are some of the open area of research that can be used by combining these three areas, that is big data analytics, artificial intelligence, and IoT. And I'll just reiterate on what I have just explained to you. I, I, I just want to emphasize here that the data or the big data that we are dealing with comes from the sensors, and we cannot separate the two. So we could combine these various areas or facets of research, and by combining them, we can use them as a combined research approach to form a quality research article. And these are some of the SCA indexed research article that I, published using these basic areas, that is big data, IoT, and artificial intelligence. I combined all these three areas, and I managed to, you know, make these quality research articles. So it's a kind of an encouragement for you as well. If you want to publish some quality research areas, you can combine these areas, and it will be very useful for you to do some quality re- research. I will share this PPT with ma'am, and she will share it with the interested faculties. So this is one of the open areas of research that I wanted to introduce with you. Now, I want to introduce another area of research here. Yeah, sentiment analysis. As I have told you, that sentiment analysis is an important part of your big data analytics. So next, I will be studying. No, first I will just introduce you. Yeah, let's do this. Okay, now what we are going to do, dear faculties, we are going to learn to use some real-time big data analytics tool. And now, first, I will just explain you. My screen is shown, ma'am. My screen is shown to you. Is it visible to you?
Yes, sir.
Okay,
Yes,
fine,
sir.
fine. Thank you. So first, I would just like to explain to you some of the advantages of this tool that we will be using. This tool is called Simulink. Okay, it's a part of your MATLAB. The advantage of this tool is, let me just show you. It's opening. Yeah, this is your Simulink. Okay, the advantage of this tool is that you can actually use these inbuilt blocks. You can actually use these inbuilt blocks to get an output. Suppose if you are using big data analytics in real time, you want to change any part of data, you want to alter any part of data, or you want to obtain an output. Yeah, or if you want to obtain an output, so for that you can use this tool. The advantage is that you don't have to write a single line of code here. I will do one thing now. I will show you that how to use this tool, and I will compare. I will implement big data analytics by using this tool in real time. And the task that I am doing, that I'm going to perform here, I'm going to replicate that task in Python programming, and you will see the uh, advantages of that tool. That in if I perform a specific task called task A. Yes,
Sir, sir, your screen is not visible, sir.
my screen is not visible.
Yes,
Okay,
sir.
please wait a second. Just a second. Is it shown now, ma'am?
Yes, sir.
Okay, fine. Thank you. So what I was explaining to you, dear faculty, is that the advantage of this particular tool will be that it will perform the real-time big data analytics, and it will not need a single line of code. Everything will be done by using blocks. And what I will do, I will perform a task called task A. Okay, I'll perform a task by using this particular tool, and I will show and I will perform the same task by using Python programming. And you will see that how the Python programming requires a large amount of coding to implement a particular big data tool, whereas by using this tool, Simulink, you don't have to do a single line of programming. So this is the advantage of this particular tool. Um, Before we start, I would just like to uh, show you a video that I made for you just yesterday. Okay, I'll just play that video for you. That video will give you an introduction of how to use this tool. After that particular video, I will explain the same thing again in a more proper way. I'll just play a brief video of how to use this tool that I made for you yesterday. And after that, I will be implementing a particular big data analytics in real time by using this tool. Let me just play a video for you. Ma'am, is this video visible to you?
Yes, sir.
Okay, fine. Thank you. So th- this is the video that I made yesterday, and this video gives you an introduction of how to use this tool. It's a brief video. I will just play it for you, and after that, I will explain this tool again myself for you, and I will implement a particular problem of big data analytics for you in this tool. Ma'am, my voice is visible in this video?
Sir?
Ma'am, I'm asking that my voice is audible in this video?
No, sir.
Okay, fine.
Sir, what happens is,
Sorry, ma'am.
sir, in this video, your voice is not audible, sir.
Okay, that's what I asked you actually. No problem. So I'll just introduce you. So for, actually, what we want to do, we want to implement big data analytics. Okay, so let's consider a scenario, and in that scenario, let's consider that we want to implement the incoming, you know, customers on a railway station to buy tickets. Now we will see that how those incoming customers that are coming in the station are processed, how their data is handled, how their data is being used, and how their data is being analyzed and processed in real time by using this tool. We'll see that. So initially, or at the first stage, what we will be doing here, we need a time-based generator. For that, what I have done, I have gone to sim events, and in this option, sim event option, I have gone to generators, and in this particular tab, I have gone to entity generators. Now there are two options here. First is the event-based entity generator, and second one is the time-based entity generator. What this time-based entity generator do? If I move the mouse over this particular entity, it says it generate entitles using integration times from a signal or a statistics distribution. So I want to use this time-based entity generator to model or to implement the incoming customers coming into a railway station. Now, this is only an example. Uh, Faculties, this is only an example. You can use these blocks for any application. For example, you can use it for number of employees coming into an office, or you can use this example for any other application, and you can change the data or the number of people or individuals coming into an office or into a airport or a railway station according to your own wish, and you don't have to code at all. So I will just show you. I will just right click on this. It shows add block to a new model. I'll just add this to a new model. This is my new model. Let's save this first. Save this by the name untitled one. Okay, I have saved this. Okay, it's showing it does not accept space, I guess. Yeah, now it is saved. So this is time-based entity generator. This can be used to s- study, simulate, or explore the data of any size. I'll just open its properties. By opening its properties, you can see there are so many types of diverse options that we can use. Okay, so I will just go to its distribution. It's showing me three options: whether I want a constant distribution, whether I want a uniform distribution, or whether I want exponential distribution. So I want a uniform distribution. Now it's showing me option of minimum to maximum. Say minimum, I want zero customers or passengers coming to a railway station or into an airport. And as a maximum value, I can give any value. I can give 1,000 or 10,000 or 1 lakh, 10 lakh, crore, whatever. This basically is a wonderfully designed graphical user interface tool that allows me or allows any user to implement big data analytics in real time without going into a complex code or anything like that. I will show you that how to do it by using Python code as well later, and you will see that how effective this tool is. So at present, I will just say I need a maximum of 20 passengers coming into a ticket counter, and I'll just press OK. So this is my time-based entity. Now, if I need to get an output of anything in this tool, Simulink, I need to get a sync or a scope. Okay. To get a sync, I will again go to my Simulink library. I will click on syncs. These are several kinds of syncs that are available to me. Now, again, I have two options. Either I should write code for them in the Python, or I can use these inbuilt blocks straight away. Attribute scopes, discrete event, entity sync, instantaneous. These are all my syncs, and I can use any of these syncs for my purpose. I will use instantaneous entity counting scope. I'll again right click it and add it to my block or my model. This is my model. This is the sync, and I will just join these two. Join these two. I want to run this iteration for 200 rounds. I press here 200, and from here I start the execution. This is the execution. I have started it, and this is my initial output that I obtained. This is the initial output that I am obtaining. As you can see that up to 200 iteration or up to 200 rounds, there are various passengers or customers coming into a railway station or an airport or whatever system that we are implementing or simulating. There are various kinds of customers or individuals coming into a railway station. So this is initial stages. This is just a straightforward simple model. In the afternoon session, I will build on this model and I will show you that how I can make or I can construct a complex big data analytics structure using this tool. And I will show you how to obtain output from that. And apart from that, uh, I will make you do some hand-on practices as well on some of the projects or big data analytics research problems on this tool in the afternoon session. So we will continue building on this particular tool by adding more blocks and more structures from the Simulink library to implement big data analytics in real time. Ma'am, over to you, please. Ma'am, are you there?
Sir?
Yes, ma'am. All to you, please.
Okay, sir. Okay, sir, shall we start at 2 o'clock, sir?
Yeah, yeah. We can
Okay,
continue
sir.
at two.
Okay,
Definitely.
sir. Thank you.
Thank you very much.
Thank you, participants. The again afternoon session will start at 2 o'clock. Thank you. Suresh, sir.